In this lesson, we're going to look at the systematic nomenclature of carboxylic acids and acid derivatives. A carboxylic acid is a carbonyl compound with a hydroxy group bonded directly to the carbonyl carbon. A carboxylic acid is another suffix-modifying functional group, replacing the E of the parent alkane with oic acid. In the first example, you can see we have a 2-carbon carboxylic acid. So this is going to be ethanoic acid. Ethanoic acid is almost always referred to by its common name, acetic acid. Acetic acid is actually what makes vinegar vinegar. In the next example, we have a 5-carbon chain carboxylic acid, so this is a pentanoic acid. Just as with other suffix-modifying functional groups, the carbons of the parent chain are numbered starting from the end closest to the functional group. So here, we would number the carbons from right to left. You'll note that the 1 locant value is not included in the name, and that's because for carboxylic acids and acid derivatives, the carbon chain only extends in one direction from the carbonyl carbon, essentially guaranteeing that the carbonyl carbon will always have the locant value of 1. Remember that suffix-modifying functional groups have a numbering priority over prefix groups. So in this example, we have a 6-carbon carboxylic acid, and the carbons are numbered from right to left, giving the carbonyl the lowest number possible. That places the methyl substituent on 5, so here we have 5-methyl-hexanoic acid. Another frequently encountered carboxylic acid with a common name is benzoic acid, which is a benzene ring attached directly to a carboxylic acid functional group. Up next, we have acyl halides, which are carbonyl compounds that have a halogen bonded directly to the carbonyl carbon. Acyl halides are suffix-modifying functional groups using the OYL halide functional suffix. So in the first example, we have a 2-carbon acyl halide, the halogen being chlorine. So this is going to be ethanoyl chloride. Ethanoyl chloride is almost always referred to by its common name, acetyl chloride. If we look at the next example, we can see we have a 5-carbon acyl halide, and this time it's a bromide. We number the carbons of the parent chain starting from the end closest to the carbonyl, which places the methyl group on 3. So here we have 3-methyl pentanoyl bromide. Note that the halogen is not added as a prefix, it's not a halo substituent. The halogen is incorporated into the suffix with the entire halogen name. Next, we've got a bit of a quirky functional group, acid anhydrides. An acid anhydride is a carbonyl compound in which 2 carbonyls are bridged by an oxygen. Acid anhydrides are a suffix-modifying group using the OIC anhydride functional ending. Because acid anhydrides generally will have 2 carbon chains, each with their own carbonyl, there will actually be 2 parent chains in the name. When the anhydride has 2 different groups attached to each carbonyl, it's referred to as an asymmetric or mixed anhydride. If we look at this example, we can see that the 2 carbon chains that contain a carbonyl are a 3-carbon chain on the left and a 4-carbon chain on the right. So this is the anhydride form of a mixture of propanoic acid and butanoic acid. The 2 acid names are listed alphabetically, followed by the word anhydride. So here we have butanoic, propanoic, anhydride. If the 2 groups attached to the 2 carbonyls of the anhydride are the same group, it's referred to as a symmetric or simple anhydride. If we look at this example, we can see that the carbon chain on the left is 2 carbons long, and the carbon chain on the right is also 2 carbons long. A 2-carbon carboxylic acid is called ethanoic acid. Because the oxygen is bonded to the same acid residue on each side, we list the acid residue name only once. So this is ethanoic anhydride. But remember, ethanoic acid is almost always referred to as acetic acid, and so the common name for this compound is acetic anhydride. If we look at the next example, we can see that the carbon residue on the left is a 3-carbon chain, and the same 3-carbon chain is found on the right. A 3-carbon carboxylic acid is propanoic acid, so this is propanoic anhydride. An ester is a carbonyl compound with an alkoxy group bonded directly to the carbonyl carbon. An ester is a suffix-modifying functional group using the O8 functional ending. An ester will typically have 2 separate carbon chains, one attached to the carbonyl and one attached to the oxygen. And it's important to recognize that the parent chain will be the longest carbon chain attached to the carbonyl. So if we look at this first example, we can see that the molecule has 2 separate carbon chains, a 2-carbon chain on the left that includes the carbonyl, and a 4-carbon chain on the right attached to the oxygen. And that means that the 2-carbon chain on the left must be the parent chain, because it's the longest carbon chain that includes the carbonyl carbon. So in this case, a 2-carbon chain is ethane, we add the O8 ending, so this is an ethanoate ester. The name of the alkyl group that makes this an ester is placed directly in front of the parent name. In this case, we have a 4-carbon chain attached to the oxygen. That's a butyl group, so this is butyl ethanoate. And notice that the word butyl is separate from the parent name. There's a space between the parent name and that butyl. Esters with a 2-carbon chain parent chain are almost always referred to as acetates. So in this case, the common name for this would be butyl acetate. In the next example, we see a parent chain with 3 carbons, so this is going to be a propanoate ester, and we can see that it's a methyl group that's attached to the oxygen. So this is methylpropanoate. If we look at the next example, we can see that the parent chain has 4 carbons, so this is a butanoate. Because the parent chain has a substituent attached, we need to number the carbons of the parent chain to determine its locant. So we number the carbons of the parent chain starting on the end closest to the carbonyl. That places the methyl group on 3. As always, the methyl substituent is placed directly in front of the parent name, and the propyl group, the group that makes this an ester, is still placed in front of the entire name. And that means that the name of this compound is propyl 3-methylbutanoate. Notice that the propyl and the methyl were not alphabetized. The alkyl group attached to the oxygen of an ester is always placed in front of the entire name, separated with a space. Because esters typically involve 2 separate carbon chains, it is possible that those 2 carbon chains could loop back together, forming a ring. A cyclic ester in which the carbonyl is in a ring is referred to as a lactone. We're not going to learn how to name lactones, but I do want you to be aware of what they are. They're simply cyclic esters. Up next, we have amides, which are carbonyl compounds with a nitrogen bonded directly to the carbonyl carbon. As with all the other acid derivatives, amides are suffix-modifying functional groups, using the entire word amide as the suffix. So in the first example, you can see that the longest carbon chain that contains the carbonyl carbon is 2 carbons, making this an ethane derivative. We drop the E, add the entire word amide, and this is now ethanamide. Ethanamide is almost always referred to by its common name, acetamide. In the next example, we can see we have a 3-carbon chain that contains the carbonyl, making this a propane derivative, so in this case we have propanamide. It's possible that an amide could have carbon groups directly bonded to the nitrogen atom. This could result in 2 or even 3 separate carbon chains in the molecule. But again, remember that the parent chain will always be the longest carbon chain that includes the carbonyl carbon. So in this example, we can see that the longest carbon chain that includes the carbonyl carbon is a 6-carbon chain. So this is going to be a hexane derivative. Because the molecule has a substituent on the carbon backbone, we need to number the carbons of the parent chain, again starting from the end closest to the carbonyl. That places that methyl substituent on 3. Notice that in this example, we also have an alkyl group attached directly to the nitrogen atom, in this case, an ethyl group. Substituents placed directly on the nitrogen of an amide are given a capitalized, italicized N as the locant value. Putting it all together and alphabetizing the 2 substituents, we get N-ethyl 3-methyl-hexanamide. Because amides can have carbon chains attached to the nitrogen, it is possible that a carbon attached to the nitrogen could loop back and attach to the carbonyl, forming a ring. A cyclic amide, in which the carbonyl carbon is contained within a ring, is referred to as a lactam. And we're not going to learn how to name lactams, but I do want you to be aware of what they are. Lastly, we have nitriles. A nitrile is a compound with a carbon-nitrogen triple bond, which means that a nitrile isn't even a carbonyl. If you look at all of the carboxylic acid derivatives, you can see that there's one thing that they all have in common with the carboxylic acid functional group itself. All of these compounds possess a carbon with 3 bonds to an electronegative atom. And of course, a nitrile with a carbon-nitrogen triple bond will also have a carbon with 3 bonds to an electronegative atom. And that's why they're almost always included in discussions with carboxylic acids and acid derivatives. A nitrile is a suffix-modifying functional group using the entire word nitrile as the ending. And note that the E ending of the parent alkane is not dropped. If we look at the first example, we can see that we have a 2-carbon chain nitrile. A 2-carbon chain parent chain would be ethane, and so we attach the entire word nitrile to the end to get ethane nitrile. You've probably noticed by now that all of these 2-carbon chain acid derivatives have common names, each one having that acid part of the name, and this is no exception. Ethane nitrile is almost always referred to by its common name, acetonitrile. In the next example, you can see we have a 3-carbon chain nitrile, so this would be propane nitrile. Don't forget to include the carbon of the nitrile in the parent chain.